Hi students, helping you with Tracing While Loops worksheet number 2 here in a Intro to Computer Science course using the Python programming language. For the purposes of this video, the purpose of the video is not just to show you how while loops work, but also to review or teach what a sentinel value is, and overall just how to be very exact in your prediction of what a segment of code would print out. So here goes, let's begin. Theoretically, and actually in actuality, you should be able to type this code into a Python editor, such as the website Replit or idle that comes with Python from python.org. So if you were to type this in, you would be able to get the final answer. Notice how I put hashtags here to comment out these two columns that I just used for scratch purposes. So let's begin. So in the beginning here, we have the line of code sum equals 0. I've already done that for you in this printed worksheet, but you can go ahead and put a 0 over top of that 0. Done that. Num equals 0. Done that. 0 goes there. Okay, welcome to your first while loop. A while loop needs a control expression that simplifies to either true or false, similar to an if statement. So if this is true, we go through the body of the loop, and the body of the loop is this set of indented statements that are lined up perfectly with each other and indented. So this is the body right here, and it only executes if this control expression simplifies to true. Well, let's check it out. Let's evaluate it and see if it is true or false. Well, you should know by now in this course that that symbol right there is called the not equal to symbol. Math teachers, math professors, they might refer to it that way. Elementary school teachers, that's what they mean. But here in code, it's an exclamation mark equal symbol, or at least it is in the Python programming language. So we ask carefully, is num not equal to -1? Well, num is currently 0. And so basically this simplifies to 0 not equal to -1. So is this overall a true mathematical fact, or is it false? Well, it's true. I think we're recording now. Yes, sorry, that was a brief break for an NSA check-in. Now back to the eraser tool here. And overall, that's a true thought. So I put a little T with my pencil there, meaning true. That's simplified to true. And we do go through the loop. So an assignment statement with this equal symbol works from right to left. This value, simplified, gets assigned into the variable sum. While currently sum is a 0, currently num is a 0. 0 plus 0 simplifies to 0. That 0 plugs in the sum. Please do cross out the 0 and put another small 0 below it, because that's how exact I like to be when we trace code. Next, we execute the line of code num equals something or other. You were supposed to have read the directions, probably better than I did when I made this video. The directions tell you that you're supposed to assume that the user inputs this sequence of numbers when he or she is expected to input a number. So the input command in Python doesn't work with turtle graphics, for example, but it does work in the console window in such a way that if the user types in a 3 to the keyboard, the 3, which is temporarily treated as text, because of the int command with the set of parentheses there, the double quotes are stripped off of the 3, kind of like turning a zip code into a number, and that number 3 is successfully then plugged into the variable num over here. So crossing that 0 out, putting a 3 there is the way it works. I don't want to get into any more details about int. It just is needed for this program to work correctly. Back to tracing the while loop. Now that I've executed that line of code, the computer goes back up to the top of the while loop, and it keeps going around the while loop until a false occurs in its control expression at the top. So in other words, a while loop, sorry, I'm erasing incorrectly here. In other words, a while loop works similar to how that spinny ride called the Himalaya at the Reading Fair and I think Ocean City, New Jersey. There's a ride like that that I love to get on, but I get dizzy. But it goes around and around and around and around until the person working the ride yells out, false. As soon as the ride operator says false, it stops. We just don't know how many spins around the loop we're going to have. This is not the same as the way a for loop works, where because of the way range often is used with it, you know exactly how many times a for loop works because of some formula called high minus low, or the number 4 in the case of my example there. But a while loop, you really don't know. Now in this exercise, I'm telling you just to assume that the user inputs the numbers 3, 4, 2, and -1, but pretend that you don't know those numbers ahead of time. They're all in the brain of the person running the program, the user as we call him or her. Okay, so where was I? I just got to this line of code a second time. Num is currently 3. 3 not equal to -1 simplifies to a true, I meant to say. So we do go through the loop a second time. Working from right to left, sum plus num is currently 0 plus 3. That 3 plugs into sum, which means that we put it under that column carefully. Then the next number that's unused here is a 4. The 4 plugs into num, so carefully put that over there. We go back up to the top of the loop. Trust me, it's true again. I know it's getting messy. But next, we do sum plus num. At this moment, different from the moment before, sum plus num is 3 plus 4, yielding a 7. That 7 plugs into sum, crossing out the 3 that was there. The next number that's inputted by the user is that 2. 2 gets plugged into the variable num. Back up to the top of the for loop. It does execute again. Oh, by the way, special hint. This loop is going to keep going around until the person inputs a -1. So hopefully eventually they input a -1. Well, anyway, they just inputted a 2. Currently sum plus num is 7 plus 2 yielding 9. That 9 plugs in for sum, crossing that 7 out. And then the user gets to input another number, and finally he or she, we're just assuming, enters a -1. The -1 gets inputted. It's temporarily stored in num. Carefully squeeze it in here to be accurate. Then the computer, which is quite dumb, it goes back up to the top. It can't see into the future. It doesn't know that -1 is special yet, but it goes back up to the top of the while loop and it evaluates this expression. It puts a -1 in there and it asks, is -1 not equal to -1? Well, that's false. -1 is equal to -1. So it'd be false to say that it's not equal to -1. So anyway, it's false. The ride operator on that spinny ride just said false instead of like true 100 times. So you're finally done on that ride. And it stops. In other words, the loop terminates. We don't execute any code that's inside the loop anymore. And we do execute whatever code is in the main program out here, indentation-wise in Python. This line of code executes. So unlike Turtle Graphics, where we can use what's called pen.write, the print command is what's used in the boring text console output window. And I was kind of like crammed up over here. I want to be very careful so that people know that that was the final value there with a 9. -1 was the final value. So I want to show what the output is. So the output is whatever gets printed. Instead of hello world printing, it prints all this. So working from left to right in the parentheses, sum is currently 9. And for technical reasons I don't want to elaborate on here, kind of the opposite of the int command, the opposite of the int function is the str string function. So the 9 has a set of double quotes imaginarily placed around it. That's what the str does. And that just makes it then legal to glue, or as we call it, concatenate, that 9 with a blank space. So a 9 prints out with a blank space that I just can't see there. And then another plus, meaning add something else, tack something else onto it. Num, which is currently -1. Don't ask me why I'm having you print the -1, but I am, so it's part of this worksheet. And the -1 would go over here further to the right, carefully showing a single space there, and that is the output of this code segment. The final values are 9 and -1. Hey, let's take back up a little bit and look at the big picture here. This code segment just added up a bunch of numbers that were inputted by the user. Let's just pretend we went miniature golfing, and on hole number 1, it took you 3 putts. On hole number 2, it took you 4. It's a very short miniature golf course. On hole number 3, you shot a 2. So on the miniature golf course, those were your 3 scores, and now the game's over. The people working the miniature golf course hold up a -1 sign, meaning we're closing up, you got to leave, that's the end. Does it make sense to add up the -1? That's sort of the way they're indicating that it's time to leave, that they're closing. Does it make sense to add a -1 to your golf score? Absolutely not. So unlike question number 2 in this worksheet, where I think the -1 illogically ends up being added into the running total, I don't think the coder intends for the -1 to be added into the running total sum. Just saying. I don't think that's logical. Bad coders sometimes cause software to not work right. And that's just the way it is. Maybe they didn't take a class like this. So now cleaning this up, you do see that 3 plus 4 plus 2 is 9, and that is what we displayed as part of the output. Okay, moving on to number 2, I'm going to go fast, like you might if you end up taking the AP Computer Science A exam that often has questions like this. Or if you get a job at Google or Snap or Hulu, where some of my students from years ago currently work, they might be writing code a little bit more complicated than this, but that certainly uses while loops somewhere, I would guess. I would bet, actually. Okay, here goes. Real fast in the color blue through exercise 2. 0, 0. This is true from the very beginning. And make sure you don't put a -1 in num, because then that will be false, and you'll never, your hot air balloon will never lift off the ground. So anyway, it was 0, not -1. So far so good. Okay, the first number inputted here is the 3. So a 3 goes there. We add the 3 in using this fancy symbol called the compound addition operator. It's the same as this line of code up here. It just works, it's just more compact. So that 3 gets added into sum. I like to cross these old numbers out. We go back up to the top of the loop. The 4 gets inputted for num. The 4 then gets added into the running total sum. The next number that gets inputted for num is 2. That 2 gets added into the running total for a grand total of 9. And then a -1 gets inputted for a num. But because the order of these 2 body statements is different from the order of these 2, after the user inputs a -1, the microsecond after that line of code in the body executed, the computer is not logical, or it doesn't have the permission to guard against adding that -1 into sum. It just happens whether you like it or not because of the order of those 2 lines of code. Something so subtly different from another line of code causes an 8 to be put here, and that's just logically wrong. The number -1 was not a logical number that was meant to be interpreted as a golf score. It was only a number that the coder chose to use as a special sentinel value to indicate to the user how to quit the program. Often in the real world still, but a lot of times in the old days, we had situations where you could only type numbers. You could not click a mouse and click like a button that says exit or like an X in the upper right corner of a browser window. We couldn't quit things by clicking. We couldn't even talk to the computer like you can talk to Siri. There were a lot of things we couldn't do, and -1 was something that we could do. So -1 is often famous for being a sentinel value. It would make sense that for -2, but just not as much sense as -1, because why complicate somebody's life and make them type a -134 for no good reason? Like I could have put -134 in as the sentinel value here, but that would just be weird to have people type -134 to quit a program. Keep it simple, stupid. Make it -1 if you have to use a number. Okay, the output ends up being 8 space -1. Show that for full credit right here. If you're watching this video or listening to it, you would have heard that. If you're just scrolling forward to get the answers, I guess your answer will just be a rectangle because I'm leaving it like that, even though you and I both know it should be 8 space -1, just like that was 9 space -1. Okay, long video becoming even longer. Exercise 3. I heard this was hard from students that took this course in former years. Let's first just look at it as if we didn't have time to do it, because often coders have to look at something to have a sense as to whether something's correct or not before they investigate further. The sentinel value is again -1. That's what the user sees on the screen. But they accidentally at some point type in a -99, which makes no sense as a golf score or some other point of purpose of this program that involves positive numbers only. But we just have to write it off as user error. But look what happens. Once we put the zeros in here and we move forward with the 3, and it gets added into the running total, we move forward with the 4, it gets added in correctly. In fact, the 2 gets added in correctly. But let's say the person accidentally bumps the keyboard and puts a negative in front of their intended number 99. Or a hacker injects the -99 on purpose, trying to mess with us. That could happen, actually, some kind of injection attack. Well, -99 does get inputted into num whether we like it or not there. So you should have a -99 under the 2, and then the code loops back up, and we have to be strict here because the code is strict in the way it interprets itself. And we ask, is -99 not equal to -1? Well, that's true. Just like 2 was not equal to -1. And if a while loop is true at the top, that means you do execute it. So what happens then? Well, immediately you can see the problem. The -99 that's currently stored over here in num is being added in because of the plus equals to sum. And -99 plus +9, I can do that in my head. I don't need a calculator. It's -90. So -90 is what sum is, whether you like it or not. Then the computer goes back up to the top of the while loop. And now the person probably realizes, whoops, I want to quit the program. I type in a -1. The -1 gets added in. Oh, I'm sorry. It's just now adding the -99 into sum. And now we do have a -90. And now the -1 gets added in. I might have been off by 1 there. But at that point, it's false. Because -1 not equal to -1 is false. And the computer does stop executing that loop. The final answer ends up printing out as negative 90, space, negative 1, because I forgot to show you there at the end in all that confusion that the negative 1 was inputted at the after we added the negative 99 in, we put the negative 1 there, it plugged in for num, and the next time around it did yield a false. So the answer to this is the output is negative 90 space negative 1. Exercise 4. I heard that's tricky also. Probably is. Let's take a quick look. It looks similar, but this time any number greater than 0 will keep the loop going. So as soon as the user types that negative 99, whether it was by accident or not, the negative 99 that just got inputted at some point for num, when we go back up to the top of the for loop on that, on the while loop on that iteration, negative 99 greater than or equal to 0 simplifies to false. And because of that false, we stop and we execute the print statement. Now, trust me, the numbers under here are very similar to the numbers that you saw above. It's your job to fill those in. But sum at that point will be 3 plus 4 plus 2. And that 9 does print out in front of a space. And then num, which is the last number that they inputted, I think it ends up being negative 99 at that point, also is displayed because of this. It never reaches this negative 1. And in fact, it never reaches that 999. That was just extraneous information. I warned you to trace it carefully. So they did not get used. And finally, exercise 5. While I don't like to do a whole worksheet for people, I might by accident do this whole worksheet. Let's take a quick look at number 5. It's similar, but I see the word and because of this nicer control expression, it keeps going through the loop as long as we have positive numbers here. As soon as we hit that negative 1, it stops. But the sum of less than 10 must be true. So when you add 3 plus 4, it's 7, and 7 is less than 10. When you tack on another 2, 9 is still less than 10. So that true anded with this true does cause the whole control expression to be true, which means we do keep iterating through the for loop. It breaks down when, I believe, we add this 1 to the 9. For at that point, a grand total of 10 that appears somewhere in this chain. And that 10, at that point, after allowing another 9 to be inputted into num, on that next iteration, if sum is equal to 10, and even though num 9 is greater than 0, we end up with a true here, but it's being anded with 10 less than 10. That's false. 10 is not less than 10. And that, from our truth table, is when we have a 1 and a 0 under our, I taught the truth table earlier this semester. And with the word and, which I count as the strict parent, no dessert for you, false. Overall, this is false. We don't execute the while loop, and it ends up printing out sum, which at that point is 10, plus a space, and num, which I believe at that point is a 9. 10 space 9. Watch the video over and over again. Hopefully it's not too sloppy, and see your teacher for extra help if necessary. Or type these into your software to check your answers or play with it so you really learn it inside and out.